Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 15, 2025, so about a week ago. This paper introduces a new framework that achieves a clip similarity score of 0.277, a big jump from the previous best of 0.201. The paper is titled, Robust 3D Masked Part Level Editing in 3D Gaussian Splatting with Regularized Score Distillation Sampling. And as we'll see, the visual results are really impressive. The authors tackle the difficult problem of editing just one specific part of a 3D object without messing up the rest. Also, the authors shared their official implementation, and it's a great resource. On their GitHub, you'll find the complete code, detailed installation instructions, and even shell scripts to replicate their experiments. It's all set up for you to run segmentation and editing on different datasets and really get hands-on. Alright, so this first figure really shows what the authors are trying to achieve. They start with a 3D Gaussian splatting scene, which is a way to represent a 3D object using a collection of fuzzy colored dots called Gaussians. On the left, you see the original face. Then, they compare their method, RoMaP, against three others on different editing tasks. While all methods can handle turning the whole face into Albert Einstein, they fail at specific part edits. Look at the request to make one eye blue and one green. Only RoMaP succeeds. The same goes for turning the nose into an emerald. It's a striking visual proof of their improved control. Building on that idea of control, this next diagram breaks down how their system, RoMaP, actually works. It tackles two main problems. First, it creates a very precise 3D mask of the part you want to edit, using what they call 3D geometry-aware label prediction. This ensures the mask is consistent from all angles. Second, it uses a modified editing process called Regularized Score Distillation Sampling. Now, Score Distillation Sampling is a method that uses a 2D image model to guide a 3D edit. The regularized part is their secret sauce. It allows for big changes to the selected part while protecting the rest of the object from any unwanted spillover. So this next figure gives us a fantastic high-level view of the whole RoMaP pipeline. On the left, we see the segmentation. Using a text prompt for the hair and face, the system's 3D geometry-aware label prediction, or 3D GALP module, creates a precise 3D mask by analyzing the object from multiple viewpoints. Then, on the right, for the editing, a new prompt like jellyfish tentacles for hair is used. The model first removes the original hair's color, and then uses a process called scheduled latent mixing and part editing, or SLAMP, to guide the final impressive result. Okay, so after seeing that pipeline, this table gives us the hard numbers to back it all up. It compares RoMaP against several other editing methods. The most important metrics here are clip similarity and C-hype deer similarity. Clip similarity checks how well the final image matches the text prompt, while clip deer similarity is a bit more specific. It measures if the change itself actually aligns with the instruction. And looking at the results, RoMaP is the clear winner across the board, especially in that clip deer score, where it's 0.205 more than doubles the next best method. This next table then breaks down why RoMaP performs so well. It's what's called an ablation study, where the authors take their own model apart to see which pieces are most important. Starting with the baseline, they add their 3D mask, and then their special regularized loss function. You can see with each addition, especially that big jump in the clip dire score when the mask is added, that every component plays a critical role. This step-by-step improvement really proves that both the precise segmentation and the careful editing process are essential. And now, after seeing those components, this figure really puts it all to the test with a head-to-head comparison. In the top section, we see what's called reconstruction-based editing. For prompts like a man with butterfly lips or a goat's head, the other methods really struggle. They either change the whole face or produce strange artifacts. RoMaP, however, precisely edits just the target part. Then, in the bottom section, for generation tasks, the results are even more impressive. Just look at a cat with a white angel's wing instead of an ear. RoMaP succeeds beautifully, showing its superior control.